Okay guys, good morning. It's too cold outside. Sometimes I think I made a huge mistake when I came here to the United States. I want to go back to Africa. Yeah, do you know that in my country the coldest temperature I think is gonna be like around 50, 55. And if you one of the times in my country people say it's too cold. But today I think I made a huge mistake. Yeah. North Africa, North Africa. So anyway, today's date is perfect, yeah? 02/02/2022, right? If you want to have a plan to do something, today is the best day to choose, okay? Otherwise, you have to wait 1,000 years to get 03/03/2000 or 3033. Anyway, so hopefully you get a chance to finish the lab. Hopefully you don't have any issue, okay? So today we are going to go over, the principle of the TCP/IP protocol in general. I'm aware that all of us were familiar with the TCP/IP protocol, but as a security professional, we need to understand more about this protocol. We need to make sure that what do we mean by the IP address, how the IP address is going to be classified, what do you mean when you say we have, for example, subnet, when we have mask, what do you mean by the default gateway, and etc. How the protocol it looks like from inside, and this will give you an idea. If you understand how it works, so it's gonna help us in order to figure out to find out a way how can we attack the system or how can we protect the system. Yeah, 1 second, I need just to make sure that I can access from my iPad from here. Okay. Anyway, so in this chapter, we are going to describe the major concept and the aspect of the TCP/IP protocol in general. Okay, we are going to go over, every single layer in this protocol. You know that we have application, transport, internet, and the network. Actually, we're not going to focus on the network because mainly we're going to take a look to the transport and the internet. Okay, we are going to review the IP addressing schemes. Okay, we need to be sure that what do you mean by the IP address, how it looks like, how can you classify this one. If you understand how the IP address working, if you understand the porting, then now we're gonna understand, it's gonna be easier for us starting next week when we're starting attacking the system, penetration of the system. Okay? We're gonna take a quick discussion about the few numbering systems. Okay, the binary system, the octa, the hexadecimal. Yeah, to give you just a quick idea about this one, just refresh. Too few slides. Okay, and I'm aware that you know that how to convert from one system to another. So I'm not gonna cover this one in more details, but just to give you an idea. Okay. So in order for the computers to communicate, it's like people when you try to communicate with each other. We're supposed to have special way to communicate. They say a common language, and the way how can we talk to each other, right? Assume that I'm speaking different language. Actually, I'm speaking different language. I think hopefully it's English, what I'm saying right now, okay? So at least you understand me. Why? Because we know that the language has some grammar, and it looks like there's a specific protocol when I'm speaking, introduce myself, when I paraphrase or you say create or build a sentence. The same thing for the computers. In order these computers to communicate with each other, okay, over the internet, I assume that we have either it's going to be locally or through the internet, they must speak the same language. When I say the same language, that's reason in this case, we mainly know that the protocol itself. This language is going to refer as a protocols. What is the most widely used protocols? Is the TCP/IP protocol in general. Okay, or they say transmission control protocol, internet protocol. It looks like it's based on two famous protocols inside this, stack or suite or protocol. Okay? So the name of the TCP/IP protocol, stack, sometimes we call this one why it's a stack, because generally we have different layers going to be in the top of each other. Alright, that's why that's the name of the stack. From where they choose the TCP/IP. The TCP/IP protocols, these names are from the most important protocols that we have in this stack. We have one protocol is called the transmission control protocol, and we have another protocol is called internet protocol. Okay, we connect both of those one together, and we call the whole stack or suite that we have, all the whole protocols that we have, TCP/IP. It has 4 distinct layers. Okay, as we start, it depends on the way that you look at this one. If you start from let's say from the bottom here, so generally speaking, it looks like we have the network here. Okay, which is the one that's gonna be connected with the physically moving bits. Concerned with what? The way how physically move the bits from one medium or across a medium that we have. It's gonna be cable, it's gonna be wireless, you have a fiber optic, and etc. Okay, here right now we don't concern this at this moment about the network layer. And the top of this one we do have the top of the network we have the second one is the internet layer. Okay, so this one is what? Is responsible for routing the packet by using what? By using the IP address. So here in this moment, or this stack, we're going to use the IP address in order to figure out how can you communicate to. It looks like the IP address lets you the exact address where we wanted to move or transfer or forward this packet that I have, and to which address or which host computer, etc. Okay. In the top of this one, we have the transport. Okay, so the transport is going to be in the top of the internet. Okay, so the transport is concerned with what? Controlling the flow of the data. Sequence packets, for example, if you have divide the packet into sub-packet or segments, then later you need to reassemble this one on the other side, that we can take care of this operation here, the transport. Okay, encapsulate the segments, for example, with the TCP or user datagram protocol. You know that we're going to talk about this one more details later. Or mainly, if you still remember from the computer networks class, we know that we have 2 major protocols here: the UDP protocol and the TCP protocol. I'm going to take a look. Go over this one quick later. Okay. Then at the top here, the application, with the higher level here in the top, which is close to the user. It's here where the applications that the protocol, for example, HTTP and the FTP protocol is going to be operate. Okay? So you start on the top, you start the application send, create a packet to the transport add some information here, then it's going to pass to the internet, and internet is going to add another packet or another part to the packet. Then the network is going to be responsible for move that data back and forth. When you receive it from the network. Network is going to say what? It's going to pass the packet to the internet. The internet is going to check the IP address and you figure out to take a look whatever the packet that has been added at the internet side and the sender, remove it. Then after that, pass the data to the transport. Transport, you know exactly which application you communicate with. We're going to take a look later. This is going to be definitely we have based on the port number. The way that how can you know, for example, which application or transmission. Here, the connection between them based on the port number. Then based on the port number, I'm going to pass the data to whatever application running at the top. Next. Yeah, kind of. I know you know that you're aware what's going on in this part. So I promise you, today's lecture is going to be maybe the last lecture that we cover something that we know before. Starting next lecture, everything hopefully is going to be new. Okay? So this is just give you a quick overview about the TCP/IP stack that we have, or the protocol. Okay? So for each of them, it has like a specific protocol, something that's interesting here. One thing I need just to add about the network layer here. We are not going to cover this one. Not going to be our main focus here in this class. As we mentioned, here is a concern with what? With the physical moving bits across whatever medium that we have. Okay? It's the interface to the actual hardware that you connect. Network card, wireless card, whatever it's going to be, this is the connection be here. Okay? This is for the transmission. That one is more, general for the OZ model. This is the way that how we use in order for the network address. Yeah, this one, generally speaking, when you work with the TCP/IP protocol, mainly about the internet. This is standard with user internet, yeah, that work with the internet. That one, I believe it's going to be like other simple applications. That I believe, yeah. Okay. Let me check back here. Yeah, let's go back to the network interface or network here that we have. Sometimes you call this one the data link layer or the link layer here, different names here. So this one is going to be, it depends whatever the connection that we have, the physical hardware with the, say, the network hardware that we have. Okay, the physical network device that we have here, it may or may not provide this reliable delivery. This is out of our scope of this class, okay? Here we don't specify any protocol. If you take a look at the TCP/IP address here, protocol, for every single layer here, we're going to see that we're going to give you exactly more detail, what kind of protocols that we have assigned as the standard. For the network layer, we don't say anything about this one, okay? Leave this one as a flexible. For your flexibility for the protocol here, it depends whatever the internet protocol they're going to use here. So here there is no specific protocol, but there's like you can actually use any network interface available. One example, if you remember, I believe IEEE something that 802 point something. That's one kind of protocol that we're going to use here. Okay, good. So if you take a look here for the hardware itself here, so I can give you like a quick example about what kind of protocols can we have here. Here, definitely we have what for the internet? We have the IP protocol, yeah, and either we have ICMP protocol, the famous one, the internet protocol. We have the ARB or other protocols. We're gonna take a look at this one later. Okay, the ICMP. Remember that we do pinging. We're gonna use here. It'll be here this layer, the one kind of service. For the transport, we have two famous protocols, TCP and UDP. We're going to talk about the connectionless and connection-oriented. For the applications, we have a lot. You can say HTTP, FTP, HTTPS, and etc. All of them are going to be the application layer. Okay, good. Let me go back here. Okay, let's take a look now, start with the application layer from the top. We go with more details and see what kind of protocols and give a quick idea what's going on. Yeah, remember, I'm not going to go with more details. Main folks here, we need to understand or make sure that we are on the same page when we talk about the IP address in general. So this application layer here at the top, protocols, we call this one the front end to the lower layer protocol. The first thing that we can face when you start working, okay? This is, generally speaking, what you can see and touch as a user. Okay? These examples here, for example, the simple thing as doing hypertext transfer protocol, FTP protocols that allow you in order to, say, send files back and forth between client and server, and etc. Okay? Generally speaking, when this layer is going to communicate with the transport layer, because somehow when you build something back at your HTTP protocol, then you want to send packet, for example, from one website to another website, you include this one with a specific, encapsulate this one in specific packet, then you have to send it back to the lower level, right, to the transmission. The transmission is going to add something extra. Okay? How the transmission layer knows that this packet belongs to which application or this server at the application layer? By using the port number. So it's going to be connected. The port number is going to play a huge role in this point. Okay? It's like a connection, or to find out the which, the interface. Yeah, it's better to say the interface between the application and the transport layer. Okay? Those are simple examples here. By the way, you don't need to memorize them, but with the time, we can understand. You need at least to know, okay, this HTTP do something, this FTP do something else. Yeah? You don't need to memorize them. Okay, the transport layer with the second one. Okay, start from the top here. This one is going to be, here is the place where the data is going to be encapsulated into two segments. Either it's going to be TCP or UDP. Okay? So what does that mean, TCP, UDP? It depends on your application. The TCP is a connection-oriented. Okay? By the way, what do you mean by the data encapsulation? For example, if you have a protocol, okay, and your protocol is going to sending, for example, the sending host or at the sender host, they try to send a data, okay? So you're going to take this data and it's going to add it to the packet header That's the meaning of encapsulate. Take whatever data and put it in the packet header. Okay? So anyway, so we do have a TCP and UDP. TCP, Transmission Control Protocol, is a connection-oriented protocol. That means in this case, you have to make sure that when you try to communicate two parties, you try to communicate, the other party must be listening. Yeah? And you have to establish connection. It looks like we're going to perform some specific protocol or procedure in order to make sure that the other side are ready and waiting for our data to receive. Yeah? That's what is called the three-way handshake. Remember that? You have a three-way handshake that you try to communicate between two parties here. Okay? I'm going to go over this one later, okay? So I think connection-oriented. And when you say the connection-oriented here, that means we can, for example, if you have a large packet you wanted to send, you can divide this one into subset packets, okay, or the segments, okay? Then each of them has a specific unique number. So when you receive this packet, at the receiver side can rearrange or resort, makes the packet going to be in the specific order. If you send something and the receiver side didn't receive the packet yet, they can tell you, I didn't receive this one. And everything that you send, the server or receiver side is going to say, I received this packet, I'm waiting for the next one. You see that there's a kind of guarantee of the data that whatever you're going to send, you can get, make sure that whether the receiver side is received or not. Okay? Good. The other one with the transporter, we're going to take a look at this one, user datagram protocol. This is provide connectionless. What does that mean in this case? There is no need to run order to establish connection. Send the data, and I don't care about the the data is not going to be unreliable. When you say the connection unreliable, we cannot guarantee whatever you send, you can confirm that can be received. Someone can say, okay, why we need this one? Sometimes you need this one for the chat or video conference, etc. That's fine if I need to make sure that it's going to be fast. Yeah, and at the same time, that's fine if we lose some, let's say, few seconds during the transmission. Okay, good. So let's take a look at how our TCP three-way handshake works. Okay, so assume that you have. I think I need to. I'm afraid if I give myself the permission to type, all right, I'm afraid someone else is gonna intercept. Okay. Let me check this one. Make it capture. No. Oh, my bed is lost. I lost the connection. Anyway. Let's try. Yeah, it's okay. I can write. Good. Let's take a look at the handshake here. So how it works here. Assume that we have a computer A and B wanted to communicate. This is a computer, okay? So the first thing computer A is going to say is that you want to send the data first. So you have to establish connection first. So the computer A is going to send to the B special packet. We call this one sync packet. Okay? So what does that mean in this case? Hey, this is me. I wanted to communicate with you. That's the meaning here. Okay? So it looks like in this case, you want to test whether the other side is ready, waiting for your response or not, or can accept the connection or not. Okay, so it looks like, hello, this is computer B. Are you there? You wanted to communicate with me or not? The computer B is going to reply here with what is called sync acknowledgement. We're going to talk about this one later in more details. Looks like I said, yeah, I'm here. We can't communicate. Go ahead and send me the packet. Okay? Of course, sometimes you say, no, I hate you, John. I'm not interested. Maybe. Actually, not in the real, not in the internet. So anyway, then after that, the A now is going to apply. Here we say ACK to the server. To the B again, they say, okay, it looks like I said, I need to make sure that, yeah, I received your response, and now I want to start to communicate with you. This is the three handshaking. So it looks like A and B right now, both of them at this moment here, ready to communicate, to establish, to send the packet, and etc. This is what we call three handshake. I believe you know that before, actually, yeah. Now let's take a look at the most important thing. As a security professional, you need to understand, to know the critical component of the TCP header when you send something. I'm going to talk about the transmission, the transmission control protocol. Mainly, this is the main focus right now. Yep, I'm here. Okay. The TCP header, looks like something like this, okay? So I need to make sure that we understand the main component here. Okay, so we need to understand, for example, what's the source port, what's the destination, what's the sequence number, what's, for example, these kind of flags, because this one is going to be important later. When we try to perform, let's say, ICMP protocol, etc., maybe we need to set these flags. We need, for example, remember when you said you need to send the packet and you need to have the sync, for example, you're going to send sync packet. How can your system tell you send that this packet is sync? If this set, for example, specific flag is going to be set to 1 or not. How can, for example, the host knows or tell, for example, whether there's going to be you wanted to close the communication or not. So I need to have like a specific flag is going to be set to 1 in order to tell the packet or the other party that, okay, this is the last packet finished, I don't need more communication. You need to close the connection. Something like this. Okay? Good. So the TCP segment, generally speaking, consists, as you see here, consists of the data bytes that you wanted to send and the header. So it looks like we have two parts here, right? I think it's been jumped to this one. This one I have space here. So generally speaking, we took a look at the TCP segment, the one that you said they have two parts. Usually everything you want to send or to communicate or any packet is going to have two parts. The first one is going to be the header. And the second part is going to be the actual data that you want to send or you're going to encapsulate. Okay? So we are going to trust into the header. This is header. Okay, I don't know how to write this one. This is. Okay? The header is going to look like something different. So we have like a special structure. Usually the header is going to be between 20 to 60 bytes. Again, we are going to look at the TCP segment structure or the packet, how it looks like on the side. We do have almost two parts. For every single packet that we have, it's going to have the header and it's going to have like data. Now, data, whatever you want to send. The header that contains some information. What the header is going to contain? Give me more details, information about how can I forward this data from one host to another host. It depends on where it place. For the IP packet, it's going to tell me where can I find the target machine. Here for the in this stage for the transmission layer, just I wanted to tell, for example, where this data is going to go to which application. Yeah, when you say which application, FTP, HTTP, etc. How can I tell? I tell it based on the header. Okay, so the header looks like something like this. We are not going to talk about the whole thing. When the header, remember, we said the transmission and the application going to communicate or have like interface based on what? Based on the port number. So here you can say this is the source port, specific like logical address, I would say number, which specify whatever the source at the sender machine. The destination, when you use that packet received by the target machine, we need to pass this one to the specific application based on what? Based on the destination port. You got the idea? Clear? Then we have some numbers here. We have the sequence number and the acknowledgement. Remember, again, this is only the small part here in the message or the packet. So this one is the TCP, the segment that we have. There are two parts. This is the header. The whole thing, this is the whole header. And this is going to be the data. The header, again, is going to be between 20 up to 60 bytes. Okay? You see, take a look here. If you fill these data, I'm talking about the option and the padding and those are going to be, the options and the padding is going to be up to 40 bytes here. Okay? Okay. And the top, for example, the source number, the destination port number, address, etc. And that's going to be here 20 bytes, this one. So at least the minimum size for the packet or the header is going to be 20 bytes, which you have to specify the destination, the source, the sequence number, and you have to set these flags, add, etc. Okay? Good. Let's take a look and see how it looks like on the side here. So where I'm going to focus on the TCP flags, I'm interested in this part. Those flags here, then we are going to take a look to the initial sequence number here. What do you mean by this one? And also we need to take a look at the source and the destination port. Those are the most important parts here. Okay? So again, if there is no options, the header is going to be 20 bytes. Okay? And the maximum being 60. Okay, good. And that's what you're doing, by the way, when you say sync, ACK, etc. That's what we're gonna set here. Okay, so as you mentioned, you need to understand, for example, what the source and destination port, how it works, what kind of ports that we have, what the relationship between the ports and the source and the application layer, because it's gonna help you. Because if you later, these ports gonna be associated with a specific source. If you found port numbers 80, you know that there's HTTP server or service is running at the vector machine. Okay, by not just looking at the port number. So later we try to attack or target, let's say, the HTTP server, serves at the target machine. Check if the port 80 is open. Okay, great. So that's the way that we need to act. Okay. And the good thing, of course, you need to understand which ports are open and which ports are closed. Opening ports is like a clear invitation to the what? To the bad guy who said, please, come on, I have opening ports. You can use them in order to attack my system. So that's why we need to understand when you're doing the first scan, I'm going to see later. And we did this one, actually, the port scanning, remember? With the Python code. We saw that how many ports are open. Oh, those are the ports that, like, open gates that allow the bad guys, if we don't protect them, yeah, in order to access my system. Okay, the TCP flag. The TCP flag is what? Like a flags inside the TCP connection. Remember, when you have a TCP connection, this is the way that how to perform that. Remember, we have to perform three-way handshake first, all right? You send the TCP back with the sync, or sync, let's say, flag set. Then after that, you expect to receive sync ACK, back. Then after that, you have to reply with ACK, right? Those are the flags. It's going to indicate, for example, the particular state of the connection. For example, right now, I need to establish a connection. Now, I'm not going to send the back TCP back with the, let's say, finish set to 1. That means I need to close the back. The connection. No more connection anymore. Something like this, okay? And it's going to help me also in order to give me some or provide me with some useful information in order to perform some troubleshooting. We're going to see later how can we use them right now. The most used flags are sync, ACK, and fin, okay? Each of them have one single bit. So you need just to set to either to the 0 or to 1. Okay? So now we take a look then. In more details. These flags, as you mentioned, establish connections, send data, terminate connections, and etc. You ask for, or maybe mark one specific packet that high priority. You have to send it right now. Don't wait. Something like this. Okay? So those are the flags. You see, you have 6 flags. Sync, ACK, push, urgent, reset, and finish. Okay? From the name, it's clear that what the meaning of each of them. Again, if you want to see where the position of these flags, those are what I'm talking about. This is the place I'm talking about. Those, the flags that I'm talking about here. Good. So let's take a look one at a time. What if the urge or the urgent pointer or the flag is set to 1? If you set this one to the flag, that means using just to signify the urgent data. So it looks like in this case, this data is urgent. That means you have to forward it to the application layer. That's the meaning. Remember, you see that the stacks, you start with the network at the lower level, then after that the internet. When you receive the packet from the lower level, from your whatever connection, physical network that medium that you use in order to communicate, when you receive this one, it's going to be passed to the internet protocol, right? The internet protocol is going to remove the internet part, then pass to the higher level. This one is going to go to the transport. The transport now we're going to take a look. Usually you're going to do what? You do like try to collect the data at this level. Then after that, pass. Once we have, let's say, a specific number of the packet or size, I can pass this one to the higher level based on the port number. But it looks like you do caching the data first. But at this time, if we check the TCP packet and so that the urgent is set to 1 and say, no caching, you have to pass it now, quick, to the higher level, to the application source. You see that the urgent here. Don't wait, don't cache, you have to pass this one to the application layer. Okay? The other one, for example, is what? The second one, acknowledgement. This used to what in this case? For the acknowledgement. What does that mean in this case? it looks like when you have, for example, you receive something from the other side, the sender, you have to acknowledge, okay? For example, you can acknowledge a connection that is sent by the host after you received, for example, sync ACK. Remember the handshake? You send sync, the other one reply with a sync ACK, then now you're going to reply with ACK. Yeah, acknowledge. I acknowledge that I received this packet. This is TCP connection oriented, okay? This is connection oriented, state oriented. That means in this case, I can't tell if something bad, if something, any packet lost. For example, you send sync ACK and you didn't receive ACK, you know that, oh, the other side didn't receive this one. I'm going to resend it again. I'm not going to stop resending until I receive acknowledgement. Okay? Good. The other one is push function. What does that mean in this case? It's used to deliver data directly to an application. Okay, data is not buffered in this case. It's going to be sent immediately. When someone is going to say, okay, what's the difference between the urgent and the push here? There's a minor, difference here. Actually, for the urgent, the push, the data is delivered in sequence. If you have an urgent, for example, you have multiple packets going to be received. For example, you expect to receive packet 1, packet 2, and packet number 3. You received packet 1 and packet 3. Yeah? If you have a push you're going to say, wait, I need to send packet 1, 2, 3. Once you receive packet 3, I'm going to sort them in order, then pass to the higher level. If we have urgent for the packet 3 and receive packet 3 before packet 2, I'm not going to wait packet 3. I'm going to 2 until to receive. I'm going to send whatever I have to the higher level. That's the difference here. Okay? Reset. This one is going to be reset the connection. What does that mean in this case? When you receive this, that means you have to terminate the connection right away. I don't care. When someone against it, reset, stop. What does that mean? It's not finish in the normal way, but I need to stop the connection immediately, right now. Maybe, generally speaking, used when there's unrecoverable error that can happen. It's not normal way, in other words, it's not normal way in order to stop, in order to hold the connection, or stop, the connection. And remember, we talk about the TCP, yeah, protocol, connection oriented. We don't have this stuff in the UDP, okay? Synchronization here. This one is, we use this one for the initial, let's say, three-way handshake, yeah? And used to set what is called the initial sequence number. It looks like when you start, I'm going to talk about the initial sequence number in the next slide, okay? So when you establish a connection, you have to start the connection with initial sequence number, which is the one that will be here. If you take a look here, we do have here the sequence number. This one we're gonna have have a sync set to 1. We use the sequence number here as initial sequence number in order to start to establish the connection. Okay, this looks like this is the first packet that I'm gonna send it here. What else? Yeah, I believe we're almost done. Yeah, finish. From the name is clear. Yeah, this finish bit is used to end the TCP connection. I'm done. Normally everything is fine. This is the last packet. To receive the last packet, I need to close the connection. Normally, there's no problem. I said this one fin, this is the last packet. Then we can stop here. After you finish this one, if they have any reserved resource, you can clear it from the system, and you are free to go. To start to establish another connection if you want. What's the initial sequence number here? Generally speaking, the initial sequence number is defined as what? As 32-bit. If you take a look to the diagram that we have, or TCP packet that we have, it's going to be 32 bits number, which tracks the packet received by the node or the host and allow reassembling of the large packet. So it looks like I start with 100. Then you send, for example, 100 byte. Maybe the next one is going to be 101, or maybe it's going to be 200, the next one, or 300. It depends the way that, how can you send the sequence. But when you send the first 100, I don't expect that the next packet is going to be 50. It must be something larger than 100. Okay? How these two hosts are going to be exchanged their whatever initial sequence number, they're going to establish one using the 3-hand handshake. Yeah? So let me go back to the three-hand way shake in order to just go over this one more detail, because I want it now including the sequence numbers and etc. here. So again, we have two hosts here try to communicate together. Just a quick, yeah. I supposed to leave this one way at just now a few numbers, but yeah, sometimes I do dumb stuff. You are okay, guys? You still, do you need to ping you guys to see whether you are still live or not? Yesterday I tried to send, okay, great. Yesterday I tried to send you email to you to notify you about this class is gonna be online. I made a mistake. I sent this email to the student. They took this class in 2020. Yeah, it was, I told them it's like funny. It's 2 years late. Yeah. So I said I just tried to ping you to see whether it's still alive or not. Anyway, we have two computers try to communicate, right? The first one is gonna be send what? The TCP here. When you send the sync, right? In the sync here, you have to say the sequence. You're gonna have, for example, have the sequence number. Let's say, can you use X? Whatever sequence number. This is the initial sequence number, the step one. You must, when you try to establish a connection, you have to have the sync with the synchronized sequence number. And also you have to inform the server that, for example, I would like to start the communication, and this is the sequence number that the segment starts with. 100, 200, whatever. So now you see that at the other side, this is the first packet, they'll have this sequence number. We need to establish, it looks like we need to exchange this information first. So now after the established, we're done for the three handshaking processing. Now everyone knows that what the segment number that I expect is going to be received, because I exchanged it using the initial sequence number. So you send this one, okay? Then this guy is going to reply with what? Sync ACK. So the flag is going to be 1, 1 here, and the flag equal to 1. When you say 1, this means the flag. Then you're going to say here something else, okay? I need to notify that the guy that I received the sequence number, they receive your message. So in the ACK inside this one, I'm going to say ACK, going to be something, the value is going to be here. I need to add, let's say, whatever the value that you received plus 1. Or maybe apply the same one, at least to tell him that, okay, I received this number. Okay, at the same time, I need to notify the host A with my sequence number, or initial sequence number. So I can send you sequence number here, sequence equal to say, we use X, let's use Y here. Now when you receive this one, now you need to acknowledge to the B that, oh, I received your sequence number. I know what you're looking for. So I'm gonna send ACK, and here this acknowledgement I need to add, for example, Y plus 1, because just I tell you, for example, I receive your sequence number. So both of them, they can establish a reliable connection. And each of them is going to establish, actual data transfer. And each of them, you know that in the data, computer networks, when you send another packet, you have to increase the sequence number, right? You say, I'm sending the packet, for example, 100. When you receive, for example, I'm sending the packet 110 or 20. It depends on the size of the bytes that you send it for each, stage. Okay? Hopefully that makes sense to you guys. Yeah, again, yeah, sorry, it looks like it's computer network class. Yeah. But we need to go over this one just later when you know the ACK, etc. We're going to use them in order to perform some kind of attacks. So we're going to say we're going to use, for example, sync attack or ACK attack, something like this. So we need to be aware of this one. Okay. So here we have since we have 32 bits, so we have 2 to the power 32, yeah, minus 1, all the possible, now from 0 up to the power 32 minus 1. All the possible, the range or the number of sequence number that we can use is large. Okay? One thing here, someone is going to say, oh, is the sequence number important? Yes, there's some kind of attack. Try to guess, if they manage to guess, the initial sequence number, then they can hijack the TCP session. We'll try to simulate, we'll try, okay, to simulate this kind of attack later in this class. But it's very important, this one, okay? Okay, back to the TCP ports. We know that we have things here like now we're done for this part. We know what's going on with the flags. We know what the sequence number. Yeah, remember that when you apply with acknowledge, for example, x plus 1, etc., that the number is going to be stored here. Yeah, this is going to be filled something. So here it's going to be, for example, y plus 1, or it's going to be x plus 1 when it's an acknowledged number. So just acknowledge what I received. This is the sequence number at the beginning when you send x and y. Yeah, this is going to be the initial, as you used as the initial sequence number. We're done from this. We're done from this. Now let's take a look to the ports here. Those are the three main components. Okay, so what the ports here? Generally speaking, the TCP header that we have, or the packet that we have, it's going to have a 216, bits. You have 16 bits for the source, and the next 16 bits for the destination. Okay? These use as the port number. What's the port? Port is the logical, not physical component. It's the logical component, but it's going to help you in order to what? It can be assigned to the process or whatever the thread that work in the in any either computer A or B that requires, let's say, network connectivity. For example, I'm running HTTP in the host A. Okay. So how can you tell the transport port that whatever the data is going to be passed, I'm going to send the data and expect to receive data to this application or to the service or this protocol? I have to assign specific port number. So basically, this port number, the system can tell when you have received the packet, you can say, oh, this packet belongs to whom? Check the packet TCP. Oh, it belongs to the destination port, for example, 80, 80, 100, or 200. Then I'm going to pass to the higher level, pass to that guy. Okay? When you receive something, the system can say, for example, you have two computers communicate with each other. Computer A and B. A uses port 100, B uses 200. When you send the packet, I'm going to say the source port is going to be 100. To whom? The destination. When you receive the destination, please make sure that to forward this packet to the whatever process at port 200. So you see how it works. Okay. So again, the port numbers identifies the service that is running here. Good. So that's interesting here. For example, the example HTTP, we have port 80, always has port 80. And later, we can see this one using, even in the firewall, when you try to control the packet, if you got to receive the packet business, for example, I don't want from you to use web browsing or HTTP protocol. I can lock this one and say any packet has this source, or say source or destination 80, I can block this one, it's not allowed. So I can't tell why, because now we can lock, whatever the browsing thing. Yeah? How many bit numbers? Since we, how many ports are available? We have 65,536 ports, which 2 to the power 16, which is the total number of ports that we have. All is going to be zeros up to all of that one. Yeah? So, again, you can use this one in order to whether block what ports. If you block ports, that means the way that gonna help you in order to what? In order to block servers. If you block servers, that means bad guys cannot use this port in order, or this service in order to access our system. Okay? You can help, again, blocking the ports is gonna help us in order to disable unneeded servers. As you see now, if you check the Metasploitable 3, the Windows machine, if you check the ports, you're going to see many ports are open. If you check your computer and find all these ports are open, then you have a problem. You have to close them. Yeah? Because if you have any, especially we have sometimes unneeded servers. Well, I don't use this service on my computer, so why I left this one open? Closed, because someone else can navigate this one. Is so, oh, this port open. Yeah, great, let's get in. Okay? So again, I like this one. Open ports are an invitation for an attack. It looks like, come on, I'm open. Attack me. Yeah. Good. So again, as a security professional, you need to be familiar with the ports and also how can we control their use. Okay? Someone is going to say, okay, how about blocking all the ports? Yeah, great, secure, but you cannot use anything. Yeah? You cannot navigate the website, if you have a browser, you cannot send the message, etc. You cannot send email or receive email, etc. Yeah, that's one thing you can do. I mean, it looks like you disconnect your computer from the internet, you say it's secure. Yes, secure, but it will be useless. You cannot do this one. There's some ports you need to open, but you need to monitor the communication, one thing. You need to enforce the rules at the firewall. Hopefully we're going to try to do this one later. Yeah, the plan will be huge, and who knows what we can cover and what we cannot cover. Lucky us, yeah. If you want to, by the way, take a look, all the ports here, it's, by the way, no one memorized all of them. And you didn't need to memorize them. You just to be familiar with the well-known, ports, with only the first 1023 ports. You didn't need to memorize all of them. At least you need to memorize. There's a website, links. You can use Ayana, yeah, which is going to help you in order to check, what all the possible ports that we have here. If you want to check this one, you can go over this link. Let me share this one with you guys. Yeah, this one if you want. This is just to give you an idea to see, what's all the possible ports. You're going to see these are huge. And with the time, I'm going to go over, the most important ports here. Again, if you perform port scanning and you found a port open, even if you don't know this port associated with which servers, you can just Google this link and check what the exact servers. Then we can now see whether you need to close or not, blocked or not, or whether you need to maybe somehow you can utilize or try to exploit this port. Maybe the software that's installed at this port is not updated, so you can access the system. Okay, so the first one we have a port 20 and 21. Yeah, the port 20 and 21 is like the FTP protocol with the file system, file transfer protocol. You have one computer to another computer. You need to exchange your, for example, upload your files from your machine to your web server, or the server that hosts your web application or websites, for example. That's one thing. Or you need just to exchange the files between two computers. That's the way that we're going to. So port 20 and 21. Right now you can't do this one, use HTTP, but we can be able to use this one. So you're going to see port 20 or 21 and etc. Okay. The second one is just let me go over the quick well-known ports here with the servers associated with the servers. I need to go to the slides. When you try to log in, whatever FTP, you have to provide username and password. I'm sorry, it's not clear. I need just to find out, make it much clearer, find another image. But at least here, in order to connect with FTP, you have to provide username, the server that you need to access to, the FTP server. And also you have to provide username and password if you are allowed or have a permission. Then now you have like monitor, it's like your monitor divided two parts. The left maybe is going to be the local machine, and the right is going to be, let's say, the remote machine. So it's starting back, downloaded, uploaded the files. The other port's 25 with the simple mail transfer protocol, which are used in order to what here? Just in order to submit, or send email here. We don't use this one here. I think we use the other one is the SMTP. I think we use another one as a different port. We're going to talk about this one later. Okay. Domain name system, DNS server or serves. If that at open or at port 53, this one that's in this case, you have to do what? When you try to connect this one here, you connect using not by the IP address, but by the URL address, how to access the system. Yeah. Port 69 is a trivial file transfer protocol with another version of FTP. Okay. This rely in the UDP. There is no need for authentication in this case in order to perform transfer, the data. Usually we use this one in order to transfer the configuration and the routing information. The other one, port 80, yes, we know this one finally, we know something we are familiar with the hypertext transfer protocol. This is the way how to use it in order to connect to the internet. All right, this is a protocol that you use here. Websites or web server. Port 443 with the secure hypertext transfer protocol. This means that there is no encryption. This is going to have encryption here. Okay, that's why we're going to use this one 443. If you found the website or web server or communicate with using this port This is going to be great because there is no encryption. So it's interesting. We can easily try to navigate our way or access through this port. And so this is the same, but just for the secure communication or connection actually. So all the data going to be encrypted. Port 1110 was going to be the post office protocol 3. This is used in order to receiving email. SMTP for sending, this one going for receiving. If you sometimes you need to set your, for example, browser will try to connect to specific email, so you have to tell, for example, what's the POP and what is the the other one is where is it? There's a different name. What's the IMAP? I believe this is another one. Anyway, 119 is network news transfer protocol just for the network, try to connect to the news server. 135, we're going to check this one later, mainly for the Windows machine, Windows Server 2000 above. It's going to be try to, what's going to help us in order to work with the Microsoft Exchange server and also Active Directory. We're going to try to use this one later. We'll try to navigate our way through, or access the Windows server. Right now we have 2008, but I'm going to ask you at least maybe next lecture to install or to say set up another virtual machine using Windows 2016 server. Okay, in order to try to see how can you navigate our way using the Active Directory and using the RPC, etc. NetBIOS is another, session service that allow us in order to share results. You see that maybe it's not clear what kind of actual protocol doing actually, but when we use it later, right now the most important thing I need to do from you to understand, for every single service or protocol, we do going to be associated with a specific port. It's going to be like a reserved port in order to allow that server to communicate. The other one, 143, was Internet Message Access Protocol, was used for retrieving email. It's going to be more featured than POP3 here. This is just summary. What you have the most important ports here. So with the time, we're going to see how we can use them, how can you navigate them. So right now you see the port 80, HTTP. 443, HTTPS. Added. Good. Use, there is another thing, acknowledgement number. We talk about this, we use this one somehow. It's not important, but this is just, this is still part of the TCP segment header. I'm talking about the rest. Okay, we have acknowledgement number, we have a data offset, and we have reserved with another bit. 3 bits are reserved, we are not unused, and all set to 0. Okay? This is a data offset, just tell me, for example, the header length, what the length of the TCP header. I use 20 bytes, I use 30 bytes, 40 bytes, we said the header is going to be from 20 up to 60 bytes. Yeah, so you have to tell me what the actual, because I need to know where the actual data is going to be stored. It's going to be because it's one packet. Okay? This acknowledgement, remember when you said something and receive, I need to acknowledge that whatever I received. I sent, for example, I received the sequence number X, I'm going to reply with X plus 1. That I received this one, I'm waiting for the next one. Yeah, that's the meaning here. How can we, for example, check? You can do this one to check with to view the open ports. Just simple example. If you have a Windows machine, you can test this one using whatever, the vector machine that we installed the last lab. So you have to use network stat, where it's going to be with many options. You can use netstat in order to give you all the, let's say the open, all the ports are open in your machine. Yeah, we are going to work with this one later, but right now just simple way to show you what the open are or what the ports are open in your machine. Okay, later we're gonna starting next week when we start collecting information. We're gonna do how to do our penetration testing with organized way, mechanism, technique, procedure. We're gonna do this one step by step. Quick overview about the user datagram, protocol. This is unreliable. Yeah, when you say unreliable, that means this is fast. Unreliable protocol that also operate on the transport layer. So here we have a TCP and we have UDP. Okay, TCP we cover this one more details, and UDP that we have maybe is unreliable. So there's many packets or whatever we cover. For example, the flags, etc. is not going to be part of the header when you build or when you have like UDP packet or segment when you try to send it. Why it's unreliable? Because when you start sending the packet, it doesn't verify whether the receiver's received whatever, or listening, or ready to listening or not. It's not, we cannot guarantee when you send a packet or message or whatever, send it to the other side of the receiver is not going to tell me, for example, whether I confirm I received it or not. Yeah, that means in this case, in the higher level, in the application, you need to take care, if you want to have a reliable connection, etc., you have to do this one in the higher level. Okay? Not at that level. Okay, what else here? Yes, that's what I'm looking for. The internet layer here. The internet layer, we talk about this one responsible for what? Now we have source, HTTP. We have one, we need to communicate with the web server from, for example, at the remote server. Okay, the host, or with B, at the B machine. I have a packet. For example, I have create my data, create TCP header, and now I know I need to move this data to the other side, or to the host machine, or the server machine B. So when you do this one, I'm going to use the IP address. With the internet layer, I'm going to say, okay, I'm going to take whatever your packet, I need to forward this one to another machine. How can you forward this one? I need to use like a unique address. Which in this case, I'm going to use the IP address in order to take care of this one. So it looks like we have what? We have a TCP packet and the data. Then after that, this one is going to be injected as the data in the TCP IP header. Let me show you here, quick here. So here, for example, we have the TCP header. And you have here data, right? And here you can have a port number, the source, and the destination port, and etc. Right? This one is gonna be, this is the TCP. When you pass this one to the IP, now or the internet, yeah, you're gonna do what? Take whatever you have here. Now we need to add another packet with it's gonna be the IP header. Here I need to tell how can we take this one back to another machine. So here I need to specify what the IP address for the sender and the receiver. This 192.168.2.1, this is the sender. Again, this one must be passed to whatever IP address on other machine or another host in the network or in the specific network. Okay, so that's the way how can you perform that here. Here it's gonna be connectionless. An IP protocol here, we don't care whether it's gonna be we don't assume, in other words, reliability. Yeah, from the lower layers. If you want to do the reliability, the packet, etc., take care of this one by the higher level with the TCP protocol, for example, connection oriented here. Okay, so let's take a look here with more details. Again, we know that the routing is done by using the logical address, which you have a specific IP address. One thing before we go with more details, by the way, we do have many protocols here. The famous one is the Internet Protocol. We have the ICM control message protocol, the one that we use with the ping, remember? Yeah, just I need to go over this one quick here. This one is going to do what? This, generally speaking, help the network administrator in order troubleshooting the network connectivity problems. To see, for example, we did this one. We do the ping, for example, machine 1 or machine 2 or machine 3. Why do we need to ping? I need to make sure that whether I'm being able to reach this machine or not. If I reach this machine, that means my let's say network is healthy. When I say healthy, it is alive. That means there's no problem. If you try to ping a machine and the machine does not exist, that means there's a problem with the connection. So I need to fix it. Something like this, okay? So I can do this one using pinging. In other words, I'm going to use the Internet Control Message Control Protocol. This one, when you try to pass this one, when you use this protocol, I'm going to use the IP address, all right? In order, remember, the IP address is the only way that help me in order to route my connection from one host to another host. From one machine to another machine, when you send the packet, I have to use the IP address or the IP protocol, right? The IP protocol here, someone is going to say, but I'm going to use the ICM protocol in order to check the connectivity of my network. I need to ping. Why you need to use this one? So you see that I like this one, this diagram, just to show you that the same thing here. So here we have like the ICM packet, have a header and the data. This one is going to be part of the what? Of the IP header here. You have to attach, although it's going to be like, say, it's going to be subset or attached, or they're going to be sit above of the IP address or the IP protocol here. So when you create a packet as the ICMP here to do ping, in order to send this one, you have to use the IP address. You see? Make sense? Kind of. So this one, we have many ways in order to connect. We have many commands. One of them is going to be ping. When you see ping, that means just to ping to check whether the network's connectivity, and it depends on the result that you're going to come to me. You can ping a specific IP address, okay? And this is going to be specific types. So it looks like we have like, you can specify in your packet that as ICMP, you say, I wanted to do this type of the packet is, for example, in order to send the packet echo. Yeah, so I have to set the same thing that we set some flags in the TCP packet. Here we can set some packet in the ICMP header. Okay, I will show you that some, examples here. So anyway, a trace route, which is gonna tell me, give you more details. For example, I wanted to send, for example, I reach Google, for example.com. You're gonna see that show you the exact path. Okay, from here until you reach your destination, give you more details. We're gonna do this one later. Okay, so just to give you, for example, now we're gonna go to this IP address, for example. From your computer at the IT, you're gonna go to the IT server. The IT server is gonna be passed to the whatever Comcast or Xfinity or whatever. Then this one is gonna be forward the packet to, let's say, that another internet service provider. And another one is gonna show you, or let's say, move to another higher internet service provider until reach the Google website. You see that you can hop how many, for example, router and the between until reach your destination. Show you the entire path from your back from this source until you reach the destination machine. We do have the ICM type, which is the barcode. It's gonna tell you exactly what type of packet you want to send it here. For the ping and trace, well, each of them has a specific like type. And this one is gonna help you based on the type. I can tell, for example, in my firewall, if you understand the types of different types of packet of the ICMP, I said, okay, if, for example, you want to prevent that anyone ping your IP address or your machine, how can you do that? I can take a look to the here, the types here, which is going to be part of the packet, setting aside the packet of the ICMP. And to check, for example, 8. The ICMP type code, if it's 8, that means echo. I can say block, I said, if the ICM packet that I received that contains the data type is 8, reject this one. This is the one that when you send ping, you ping a machine. This is the first packet going to be arrived. It's going to be echo. I said echo. How can you specify echo? By set this, the type is going to be 8. I think I'm not going to go over this one later in more details when we try to do the ping, you sync, etc. But more details, I'm going to show you the exact packet, how it looks like, and what we need to set later. Okay? And how can you modify this one? How can you set, for example, the set that's going to be echo or going to be response? Or let's say the other one is going to be the error message echo reply, yeah? Here, when you send something, the server is going to reply to you, right? With the message, with another packet. So I can say specify 0. Or maybe I don't want from anyone to receive any reply for when he sent the packet, echo. So you can set this one and say if ICMP type, code type 0, I'm not required to pass this one from my network. I'm talking about the firewall. Let's say that someone is going to be sitting there out, say the endpoint of your network and check all the traffic, all the packet. How can you check? Based on it depends whatever protocol that you have. Each of them have some, let's say, setting configuration. I can tell. If I understand these settings, I can tell. For example, I can control the packet. Let's say fine grain it to control the packet. Whatever the packet is going to be, go or pass or not. Okay. Now, let's back to the IP address. This is the fun start, hopefully. I like this one. We talk about the IP address. I like this one. What's the IP address? Now take a look at the IP address. The IP address is like, I'm talking about the IP version 4 right now. Consists of what? 4 bytes. If you take a look at the IP address, definitely has the 4 bytes, 32 bits. It's divided mainly into 2 components. For any IP address, it's going to have 2 parts. Okay, usually we're going to have the first one is going to be the network ID or the network address. And the second part is going to be, let's say, the host address. So what's the network address? This part is going to tell you what's the physical network that you wanted to connect to. Yeah, it depends whatever. We're going to see how can you specify that. And the host address is going to tell you the machine within this network. Assume that we have a network something like this. We have machine 1, 2, 3, 4, 5, 5, and the machine is going to be 192.168.1.0. This is the network address. So the first 3 bytes tell me which is the network that I can tell. This network, there's another network, for example, 192.168.2.0. There's another network address. So there's another network here. The host here, once you receive this network, I do have how many computers can be stored here. Each of them must have a unique IP address or unique host ID within this network. We cannot have 2 computers or 2 machines have the same host ID within the same network. So if you have this problem, so when you have to pass or have forward one packet, must be go to that network or that host, since we have more than one has the same IP, host number or address, so we cannot deliver this one, right? So all of them must be have unique IP address. Again, the IP address is going to be have what? There's a 4 bytes in length, expressed at the form, let's say, usually I can use it n dot n dot n dot n. So the total here we have 32 bits. Okay, that's the total number here. All 4 bytes. This is the first byte, the second, the third, and the fourth byte. Okay. I'm going to talk about here about these numbers are gonna be from each of them gonna be from 0 up to 255, right? Because they have 8. How can you tell? We have 0, all of them gonna be 0, 8 bits, up to all of them gonna be almost to 1, right? So the minimum 0 and the maximum 255. Good. The other thing we need to look at, we can classify the IP address into what? Based on I'm talking about the classful IP address. I can classify this one into what? Class A, Class B, Class C, Class D, and Class E. I'm going to talk about these class. So how can you classify this one based on the class? Based on what actually here? Let's take a look here. Just a quick example. Above the classes here. So Class A is going to be ranging from 1 up to 226. Okay? That means the number of address bytes. I'm going to talk about this one more details later, but keep in your mind that for each class, it's going to have a range, and it's going to have, let's say, number of networks, the max or number of networks can be stored within this class. Okay? A class A, it's going to have small number of networks, but it's going to have a large number of hosts per class. They're going to be huge. I'm going to explain later exactly what. But right now, take a look. The IP address can be classified based into 2 different classes. Class A, B, C, D, E. Okay? And you notice that we have 1 to 126. There's a number 127 is not listed here. Yeah, we're going to talk about this one later. And the class B starts 128 up to 191. When you say 128 and 191, that means I'm talking about the first digit. The first byte. The first byte, 1, so it's going to be 8, going to be from 1. I remember here, 1 up 1 to 126. So that means the first bytes here. Remember, we have 1 byte, 2 bytes, 3 bytes, 4 bytes. So the first byte is going to be 100, from 1 up to 126. Here's the second byte start the number starts 128. So when you say to convert this one to the binary representation, it's going to be 1, 0, and the rest is going to be all of them going to be 0, all right? And etc. Class C, if we have the first byte start with 192 and up, you can say, oh, this is Class C. So based on the IP. So for example, 192.168.1.1 is a Class C. How can you tell? Because the first byte is 192. If a class, for example, have IP address to start with 190 point something, oh, a Class B. How can you tell? Because it's 190, yeah, and etc. The 128 address is going to be missing from the table because used for the loop back here. We use this one a special way in order to handle the data here. Okay, the loop back just allow you in order to communicate within the same network. Okay, it's not assigned to a network device. It's not valid IP address. Again, local loopback is like address is used to let the system send the message to itself to make sure that the TCPIP stack is stored correctly in that machine, etc. Class D and E are reserved for the multicast and experimental addressing and aren't covered in this course, and we are not going to use them here. We cannot find this one in the class D and the class E. Okay? So, let's take a look one at a time here. Another way, by the way, to work with this one, since 4 bytes, we can use an octet. Okay? An octet is going to be represented as 1 byte or equal 8 bits. Okay. I'm going to go with this link later. Okay, back to this hint. Let's now take a look at the class A with more details. If you take a look at the class A here, this is the way how to work. Remember, we said we have 4 bytes, right? And this, and all the IP address is going to be divided to the network ID and the host, right? So this is the network host or network ID or the network address. This is the host address. So here we have what? We have 1 byte, comma, another byte, dot, third bytes, right? We have 24 bits we can use in order to use as a host ID. Okay? And the network ID or address is 8 bits long. This is the network ID. Start from 0. This, I mean, the binary or the first binary bit is going to be 0. I will show you why this is the case here. Okay? So remember, this is going to be start from 0 up to 126. If you take a look at the binary representation to 126 here, you're going to see, let me do this one here quick. I'm lazy. Yeah. This one actually going to be this one. So 126 in the binary representation, and going to be 0, 1, 1, 1, 1, 1. Yeah, 1. Let me count. 1, 2, 3, 4, 5, 6 ones. And 1, 0. So here 6 ones here and 1, 0. So always the first bit here always equal to 0 here. This can be represented from 0 up to 126 because the maximum number it's going to be in the network ID, it's going to be 126, can be represented like this. You see that? That's why the first bit is going to be 0. Here I have 7 bits in order to represent from 0 up to 126. Make sense? So that's why the first bit is going to be 0 here. Good. What else here? Let's see how many network ID, how many possible network ID can I have here? You have 7 bits. Yeah, you can use them. So the maximum number is going to be here what? 2 to the power 7, yeah, minus 2. I will get back to the minus 2 because here we mentioned that something. Let me go back here. In order to try to compute, for example, the total number of network or the total number of host IP address, 2 IP addresses are not counted in general. Yeah, so you have to take them out on this. Oh, the first one, all of them going to be zeros, and all equal to 1. So always you need to remove two IP address for every single network. The simple thing that we can use that, the first one is going to be the network ID. And the last one is going to be used for the broadcast, which is going to be 2555. All of them are going to be 1111. So we need, every time when you compute how many networks you have to remove this one by 2. Okay, because it's going to be like reserved. Okay, so in this case we have 2 to the power 7 minus 2. Yeah, we end up, we have the maximum network, we have 126, sorry. The maximum number for the network. If we go back here, you see that the number of networks is 126. Okay? How many host bytes for the class A? It's going to be 3 bytes, right? How many total number of hosts can I have here? If you, in order to compute this one, you see that we have 3 bytes. 3 bytes, that means we have how many bits here? It's going to be 24. So 2 to the 1 of 24. I'm going to give you the numbers here. And all is minus 2. In order to remove, I need the all zeros and let's say the all ones. So we end up, we have in this case, a large number 16,777,214. Possible IP address or host can be for every single network. Oh, that's great. You see that a huge number. You just have to compute the maximum number of how many network ID, how many host ID can. The host to the power host, number of bits of the host minus 2, and the network key to the power, whatever the number of bits in the network minus 2. Good. So again, just speaking, the address that you need to remove, actually for the host, I need to remove 2 addresses. The first one is going to be all zeros, and the other one is going to be for the broadcast. Here for the network ID or the address, I need to remove 2 addresses, which the first one is going to be all is going to be zeros, and the other one all is going to be 1 zero. It's not allowed to have. Good. This is IP address 1 for A. For B, sorry, class B, it's gonna be the same thing. B is gonna be what? Now we increase. Remember we said starting from what here? If you check the class B here, it's gonna be starting from let me go back here. Just to have to go back to the to be the same page. Class B 128 up to 191. If you take a look, 128 here, the smallest one, if you take a look, it's gonna be 10, the first one always. Right? Again, if you take a look to, let me say 128, and binary, it's gonna be, so 100, and binary is gonna be 000000001. So always 10 start. This is the minimum one. So that's why the first 2 bits is gonna be 10, and there's up. Okay. Okay, class B here. So you can count in this case how many networks, possible network to the power 14 minus 2. Yeah, but how many? It's gonna be around 16,384. How many possible hosts per network to the power 16 minus 2? Well, it's gonna be 65,534. I do have the numbers here. I don't memorize them. Okay, good. So 2 divide. The class C here, you see that the class C, sorry. I know that the time is up. Thanks, guys. Sorry, I saw the people leaving the class. I said, why they are leaving? You let me alone. Anyway, see you Monday.